Hello students, I am Dr. NAVNEET KAUR, Associate Professor in Department of Electronics and Communication Engineering, SIRT College, Bhopal. Today I am taking my next lecture on subject Signals and System. The topic of my today's lecture is Inverse Z Transform. In my previous lectures, I have already discussed about Z transform and its properties. Now, in this lecture, I'll be discussing about inverse Z transform. That means if I have already calculated or if I have any signal in frequency domain or in Z domain and I want to change it to time domain, then I have to take the inverse Z transform of the given signal in frequency domain. So, this lecture will cover the method for finding out the inverse Z transform. Now, coming to the formula of the inverse Z transform, it is given by 1 upon 2 pi j integration over a closed path. Xz is the Z transform of the given signal. Z, which is the complex variable, raised to power n minus 1 dz, where C is a counterclockwise closed path which is encircling the origin and is entirely in the region of convergence. And all the poles must be inside the contour C. Now, the method which is used for finding the inverse Z transform is partial fraction expansion method. Now, suppose if I have Z transform of any signal in the fraction form, that means my numerator and denominator polynomial is given as P0 plus B1 Z inverse, B2 Z inverse, Z raised to the minus 2 till Bm Z raised to the minus m. This is my numerator polynomial, and denominator polynomial is given by A0 plus A1 Z inverse plus A2 Z raised to the minus 2 till A to the power 8n Z raised to the power minus n. Here B0, B1, B2 and Bm are the coefficients of the numerator, and A0, A1, A2 and An are the coefficients of the denominator. Now here m is the degree of the numerator and capital N is the degree of the denominator. Now the first step which have to be performed, I have to check whether the given function is in proper form or not. Now when the function is said to be in the proper form, now it should satisfy the first condition, two conditions, then only I'll say that the given function is in proper form. First thing, that the coefficient A0 in the equation here, this A0 should be equal to 1. If A0 is not equal to 1, then the polynomial coefficients are adjusted accordingly by dividing or multiplying with the number. Now, in equation 1, an should not be equal to 1 and the degree of numerator should be less than the degree of the denominator. That is, m should be less than n. If this condition is not satisfied, then the division is carried out to make degree of the numerator less than the degree of denominator. Now, when the function is converted in the proper form, then we multiply the numerator and denominator by z raised to power n, where n is the highest power. Now, in this way, we are converting the function in terms of the positive powers of z. Now, when the function is already converted in positive powers of z, I'll obtain xz upon z. I have already xz. Now, I'll divide both sides by capital Z and I'll get xz by z. Now, when I have xz upon z, then I'll factorize the denominator and will obtain the roots. Now, the denominator will be written in the form of z minus p1, z minus p2 till z minus pn, where p1, p2, pn are called as poles. Here, we have taken the multiplication of all the factors of the denominator. Now, when we have already factorized the denominator, now I'll write down the equation in partial fraction expansion as follows. Like it will be a1 upon z minus p1, a2 upon z minus p2 till an upon z minus pn. Now, the next task is to find out the value of the coefficients a1, a2 till an. Now, any coefficient ak is calculated by the formula. I'll multiply xz upon z by Z minus Pk, and I'll take this at Z is equal to Pk. That means the root of this factor will be taken as the value of the Z. Now I'll put Z is equal to Pk in this given expression, and whatever the value which I'll get will be the value of Ak. Now this is how I'll get A1, A2 till An. Now suppose if I want to find out A1, I'll multiply xz upon z with z minus P1, and I'll take the value of this expression at z is equal to P1. Now the value will be A1. Similarly, I'll find out the value of A2, A3 and so on till An. Now, by calculating the values of A1, A2 till An, we will transfer Z to the right hand side of the equation. That means from xz by z, I'll now obtain xz. For that, the z on the left hand side will have to be transferred on the right hand side. Now, you will use standard Z transform pairs to obtain inverse Z transform. Now, depending on the given ROC, which will be given in the question, if ROC will be Z capital greater than A, which is the pole of the expression, then A raised to power n un will be the inverse Z transform of the expression Z upon Z minus A. Now, when ROC will be Z less than the pole, in that case, Z upon Z minus A expression will have inverse Z transform minus A raised to power n u minus n minus 1. This topic I have already covered in my previous lectures. In that, I have already calculated Z transform of the causal and anti-causal sequences. Now, whatever will be the ROC, that means Z greater than A will be the ROC of the causal sequence. In that case, I'll use A raised to power NUN. And when the ROC is Z less than A, that means I'm talking about anti-causal sequence. In that case, inverse Z transform will be used minus A raised to power NU minus N minus 1. So here, if my xz is of the form Z upon Z minus Pk, it will be written as inverse Z transform will be given as Pk raised to power NUN when ROC is Z greater than Pk. That means for causal sequence. And similarly, Xn will be inverse Z transform of Z upon Z minus Pk, which will be minus Pk raised to power N, U of minus N minus 1 if ROC will be Z less than Pk. That means this is for anti-causal sequence. Now, this is all for today's lecture. Now, in my next lecture, I'll take an example of finding the inverse Z transform and will use this partial fraction method to calculate the inverse Z transform. Thank you. This is all for today's lecture.